1 mole, 6.02 times 10 to the 23rd. It's easier to round that to just 6 times 10 to the 23rd when you're estimating. It's not a problem. 6 times 10 to the 23rd. Now, 1 mole of any particles, and here are the 4 basic particles that you'll be involved with. A molecule is a particle with covalent bonding, such as carbon dioxide or dinitrogen trioxide. Those are molecules. It's a particle. Formula units. A formula unit is a particle involved with ionic bonding, such as sodium chloride or calcium bromide. Those are called formula units. Ions can be as simple as an anion, the chloride ion, or the sodium ion, or it can be a little bit more complicated, like the polyatomic ion phosphate. That is 1 particle, phosphate. If I have a whole mole of phosphate, I have 6.02 times 10 to the 23rd of that particle. You don't break it up. It's 1 particle. Atoms, gold, sodium, argon, or any element. So those are the 4 basic particles. If I had a whole mole of toothpicks, that's a particle, that's 1 particle. A whole mole would be 6.02 times 10 to the 23rd toothpicks. If I had markers, here's 3, this is a particle. I could have 6.02 times 10 to the 23rd. So, particles. 1 mole of any particle contains 6.02 times 10 to the 23rd particles. 1 mole. Here's an example. How many atoms, that's the particle, how many atoms in 4 moles of gold? Au is gold. 1 particle, Au, 1 particle of gold, 1 atom of gold is Au. But how many are in 4 moles? So here's your ratio. 1 mole over 6.02 times 10 to the 23rd equals 4 moles over X. Solve. It's going to be, you cross multiply and divide. You're going to get 2.4 times 10 to the 24 atoms of gold. And if you can estimate that. 6.02 could be simply 6. So 6 times 10 to the 23rd times 4 is 24 times 10 to the 23rd. Correcting for scientific notation, that would be 2.4 times 10 to the 24 atoms of gold. Okay, so here are your 4 basic particles. 1 mole is 6.02 times 10 to the 23rd particles. Here's a quick problem, and that's it. The mole.